All right, welcome everybody. Let's do it. Creating factored form of polynomials. This will be a nice and smooth lesson. So let's take a look at this. It says sketch a polynomial with zeros at 3 and -3. So the idea is first, let's place your zeros. So where is 3 and -3? Well, you just, go on the x-axis, 1, 2, 3 over here. This is +3, and this is 1, 2, 3 over here. And this is -3. Okay, so we did the first part where we placed our zeros. Now we want to show the end behavior. So take a second and look at this end behavior, and how do you think it will help us sketch a polynomial with zeros at 3 and -3? Remember that if we have something like this, okay, right? So which one of these shows this? Notice as x goes to infinity, f of x goes to infinity. So the idea is, because this is the last zero on the right side, we're just going to go like this, because you see as x is going to positive infinity, f of x is going to positive infinity. And let's take a look over here. As x is going to negative infinity, f of x is going to positive infinity, right? And then here, we'll just connect it like this, and that's it. We're done with our graph. But the thing is, what is the factored form of this polynomial? Notice if I have -3 over here, this is x plus 3. If I have +3 over here, it's x minus 3. And that's it. And that's our polynomial factored form of this graph, okay? And someone asked me, they said, Mister, why is it when -3 it's +3, and when it's +3 it's -3? The idea is with this will be very short, but like, for example, like let's say if I have x plus 3, right? How do you get x plus 3? What do? You make it equal to 0, right? So if x plus 3 equals 0, -3 minus 3, you have x equals -3. And the same thing over here, that if I have x minus 3, plus 3 plus 3, I get that. But let's imagine if I have x minus 3 and, x equals -3 and x equals 3. Now, how do I go backwards from here? Notice that, what can I do to make this equal to 0? I could do +3 plus 3, and then now I have x plus 3 equals 0. And that's the idea, that if I have a -3, like this one over here, if I have a -3, adding 3 on both sides makes it equal to 0. So that's why when you have a -3, the binomial for -3 is x plus 3. And the same thing happens here with -3 minus 3. So that's x minus 3 equals 0. And that's the idea. Okay? What I want you to do is try and do, and that's it for this. For A, B, and C. What I want you to do is do the same thing, but I want you to try it with this polynomial, right? And this end behavior. Okay? So like, let's say if you want to see how it's done, what should we do first? Let's place our zeros. So our zeros are 3 and -3. So 1, 2, 3. And the other one is 1, 2, 3 over here. It's -3. But the idea is for this end behavior, you see as x is going to positive infinity, right? F of x is going to negative infinity, okay? And what about here? As x is going to negative infinity, f of x is going to negative infinity. And then this will be our sketched graph, okay? But now what will be the factored form of this polynomial? Notice that if I have -3, right, it's x plus 3. And if this is 3 over here, then I have x minus 3. But aren't these two the same equations, yet we have two different graphs, right? So notice one of them, this one will give us this, but for us to get this negative version over here, we need to place a negative over here to make it flip over the x-axis. Okay? All right, try and do the next one by yourself. Oh yeah, it looks like this. Okay. If you want to see how it's done, all right, so it says sketch a polynomial with zeros at 0, -4, and 4. So 0 is here, right? Where is +4? 1, 2, 3, 4. Okay, that's 4. Then 1, 2, 3, 4. This is -4, right? Okay, now what do? Let's do the end behavior. So the end behavior says what? As x is going to positive infinity, right? So you look at the one farthest to the right. This is going to positive infinity, and f of x is also going to positive infinity. Let's see the next one. As x goes to negative infinity, f of x is going to negative infinity. Okay, and then how do you connect the rest? You just kind of swoop in through like that. Okay, and this is our graph with the zeros like this, and it has this end behavior, which is important. But what's the binomial for what? Like if I have negative 4 over here, it's x plus 4. If I have this positive 4, it's x minus 4. Then how do you get the 0? Notice you just say x equals 0 and that's it. So this is just x like that. And then this is the factored form. Okay, let's take a look at the next one. Same idea, but notice how, what's the difference between 3 and 4? Take a second and think about it. What is the difference between 3 and 4? Okay, so try and do this by yourself. All right, so let's see. What are the zeros? Same idea. 0, 1, 2, 3, 4. Okay, 1, 2, 3, 4, and this is negative 4. And now this end behavior is a little bit different. You see, as x is going to infinity, f of x over here is going to negative infinity. Okay, as x is going to negative infinity, f of x is going to positive infinity. And then we need to connect the graph like that. Okay. So what is this factored form of this polynomial? Notice if it's if it's negative 4, it's x plus 4. If it's positive 4, it's x minus 4. And then this will also be x. But then what's the idea again? Notice that this is odd positive, right? Don't you remember like this idea over here? This is, when I have this end behavior, it's odd positive. So if I have this end behavior over here, where it's going like this, then this has to be odd negative. And all I need to do is just place a negative outside over there. And it was the same thing for the other one. Like I should have shown it, but I realized it would be much better. You see here, this is even positive, and this one was what? Even negative. Okay, and that's why we placed the negative over here. Right? Let's take a look at the other ones. Try and do them by yourself. Number 5. You got this. Okay. Now, if you want to see the solutions, let's take a look real quick. So where are my zeros at? Let me fix the camera a little bit. Okay. So I have negative 4, so 1, 2, 1, 2, 1, 2, and another 1, 2. So that's 4, 2, and oh wait, this one is 0. This is negative 2, and this is negative 4. Okay, so those are my zeros. Now, what's the end behavior? So if it's x is going to positive infinity, I look at my farthest 0 from the right, and notice as this is going to positive infinity, your f of x is going to positive infinity. And as x is going to negative infinity, then f of x is going to negative infinity. So notice that this is some odd positive, right? And then what happens here, you just kind of go whoop, 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 and down, just like that, and that's the graph. But okay, let's take a look. What's the factored form? If it's negative 4, it's x plus 4, x plus 2, right? How do you get that 0? That's x. So x minus 2, x minus 4, and bam, that's it. Now notice that this, like, what do you think is going to happen next? Like, what's the next connection I want you to make? Like, let's take a look at 5 and 6. 5 and 6 is the same thing, but the end behavior is a little different. Why don't you just predict what you think the next answer will be? Okay? And let's take a look. How do you do the next one? So this is what? 0, 2, 4, and then 1, 2. Great. So this is negative 2, negative 4. So then it's the same idea. X plus 4, x plus 2. And this is x. This is x minus 2. And this is x minus 4. Right? Okay. So what's the end behavior for this? as x is going to positive infinity, f of x is going to negative infinity. As x is going to negative infinity, f of x is going to positive infinity. And then you just draw it out like this. Okay, and that's the graph. But we're missing something. Notice that this is odd positive, then this one, once we have this end behavior looking like this, it's odd negative. So negative meaning the leading coefficient has to be negative over here. Okay, I hope this video helped. I will see you in the next part.